Hello. I'm actually making this video for you. I'm not going to be here today. It's Tuesday. And what you should be doing is learning these, I call them the big six, but you want to learn them not like middle school where you learn the definition, but you want to think of them more like conceptually. So you think of them conceptually. And for example, if I go over here and I look at two objects like this, I say, well, if I look at them, what can I see? I can see color. And what if I ask you, can you see mass? Can you see volume? And you say, well, this one I hear looks bigger. What does that mean? So conceptually, that means it has a greater volume. But what about mass? I can't tell. I can't tell, so I have to use a balance. I'll show you a balance here in just a minute. So I'd have to use a balance to weigh it, to be able to tell that. What about density? Well, density, can I tell who's more dense? No, because if I can't see mass, then density is mass divided by volume, and I can't tell. So I'd have to calculate density too. So the same kind of idea comes in. What is it that you can conceptualize about the big six? Now, of these big six, 4 of them are kind of belong to one little group, and 2 of them belong to another. And I want you to think about that. Which 2 seem to be different than the other 4? And I want you to think about that. Also, when I'd asked you to do this paper, I'm hoping you took a good amount of time. Maybe you had to do a little research and said, I don't know what they use to measure weight. And maybe you looked it up. Maybe you found out it was a spring scale. They measured in what units? And they're called newtons. Anyway, so yeah, I'm hoping you've discovered some things here. Again, it wasn't just busy work to get this done. It was more like, can you think about this more conceptually? So what I'm going to do today is, my main point of this lesson will be a thing called instrumentation. So we're getting ready to do, I call it the pre-density detective school. And so you're getting ready to go to school. You've already gone to school with scientific graphing, and you already know a little bit about measurement and significant figures. You already know that too. But what I'm going to do is talk about some instrumentation. So let's take a look at an instrument. And there we go. One of the first things you're going to have, this is an electronic balance. And I think you can see that pretty well. There we go. And electronic balance is pretty neat. It saves a lot of time, and it's pretty advanced. I certainly didn't have those when I was in high school, but even in college I didn't. But you guys have access to these right here. So we're very fortunate to have that. One thing to do in there is just like a ruler. You have to zero it. There's a button over here for zero in it, and then you can put things on there. Now let's say, for example, I put this on there, and the good news is all I have to do is I don't have to figure out what the last significant figure is. There's a little computer chip there that does that for me. So this thing has a mass of 53.76 grams. Okay? Now another feature that you need to know about balances is that every balance has what they call load limit, a load limit. Now, for some reason, this one doesn't say it on the front, but this happens to have a 400 gram load limit. So if I were to put something more than 400 grams, I could actually damage the balance. So you always want to think about that. If I'm putting only 200 grams on there or 400 grams, it might be able to handle it. But anything more than that, I'm going to have to go to the double pan balance. So some of you in your lab, you may have something that weighs more than 400 grams. This one's a 400 gram load limit. The other one's 200 gram load limit. So you always want to know about that. Another really neat feature about electronic balances is called the tare feature, T-A-R-E. And tare is the mass of the container. So what a neat little feature is, if I have a container like that, and it says 27.86 grams, but I'm not interested in the mass of the container. I really want to know the material in the container. So if I press 0 right here, it actually subtracts that from all the readings. So then, if I were to pour liquid in there, and this is liquid pen, anyway, I put some liquid pen in there, and notice that it says 5.38. Well, now it's only measuring the mass of what's in the container, not the container itself. And that's a neat feature called an auto tare feature. Now, you do have to be smart enough to know that if somebody before you use that, you don't go up there and put a pin here like this, oops, hang on, you have to re-zero it. Everybody got that? So you have to re-zero it, otherwise you might get a scale that says negative 26 grams. So make sure you always zero it when you come up there. Anyway, that's the electronic balance. I want to show you that when you buy these, they do come with a standard. We talked about standards last time, and this balance here, even though it's not exactly balanced, it has a little bubble here to balance it, but it's on a piece of paper, so I'm going to put it on there anyway. And that mass is a standard 200.00 gram mass. Now right now it's reading 200.004, but if you use your little mathematics, if I'm off by 0.04 of a gram out of 200, the percent error is less than 1,000th of a percent, and I won't be able to even measure that. So this is within the realm of us using the balance. Okay, so that's the instrumentation as far as the balance. The next you might use is a graduated cylinder. And we talked about this before on the graduated cylinder, how to read significant figures. But what is it that you're actually reading? And I'll draw a little drawing here. Here's a graduated cylinder. And because of what they call adhesion and cohesion together, also called capillarity, the water clings, kind of lifts itself up along the rim. And then it kind of makes a little bowl. Now, it's not that pronounced. I made it a little bit more pronounced so you can see it. But this is called a meniscus. Anyway, I don't know why they don't have womeniscus, but they just have meniscus. Sorry about that. But the meniscus is a Latin word. It has to do with the word bowl. And anyway, what you do is the companies who make these instruments, they know that a long time ago they decided that you would read the lowest part of the meniscus. So when you get your eyeball right over here, and your eyeball is going to be perpendicular to the surface, remember parallax error, you want to make sure that you're reading the bottom of meniscus. And the first thing I'm going to ask you to do when you do your little mini lab tomorrow is I want you to put a random amount of water in a graduated cylinder, and then you write down what you think you should write down to the right number of sig figs, and then give the graduated cylinder to your partner. And then they write it down, and the other partner writes it down, and then you look at all three numbers. Now, if you don't agree, then you start talking to each other, and you'll see that some people just don't know how to look at the bottom of meniscus. Well, you're going to be in like training mode tomorrow, and you have to train each other. If you don't agree what the reading is, you do something about it. You talk about it. What's your plan on doing this? Now, I'll give you one thing you could do. You could put a random amount of water in there, and you could say, I think there's 25.4 milliliters of water. And you could actually take that water over to a balance. And since you know that 1 gram of water is equal to 1 milliliter of water, you could actually check it. So if you want to know who's reading the meniscus the best, you could go over there, put a graduated cylinder on a balance, push the auto tear feature. It subtracts the mass of the graduated cylinder, put a random amount of water in there, have everybody read it, and then find the mass of the water. And so if the mass of the water should be around 25.4 grams if it's 25.4 milliliters of water. And that's how you can train each other. That's what you want to train each other to read the meniscus well. Okay, now the next thing you're going to do is you're going to have objects that we want you to find the volume of. Now, one way to find the volume is using mathematics, and I'll get to that in just a minute. But one you already know about is one where you use water displacement. So you put a random amount of water in here, and I've seen people take like 5 minutes trying to get it exactly to 35 or 40. That's not necessary. Just put it around there and read it really well. Read it really well, and you have that number. Now, what you're going to do is you're going to put this in there, but that would be pretty dumb to put it in like that. So that would break the bottom out like that. So you want to tilt it and very carefully put it in there. I don't want anybody to break any of the graduated cylinders because you're not thinking about it. Tap, 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 tap. There you go. All right. You get rid of any air bubbles. and then I'm going to read it again. And so this number here minus the original number is the volume of the object inside there. So an object displaces an equal volume of water of its own volume. And that's how you might find it with water displacement. Okay, now the other thing you're going to be doing is using things like rulers, and you already know a little bit about how to use a ruler with significant figures, and you have to watch out for your dominant eye and parallax error. You're going to be careful about that kind of thing, okay? All right, the next thing I want to do, I want to show you, though, a new instrument, and that's in your packet. And this guy right here, and he's called a vernier calipers. So these are calipers, and they happen to have a very special scale on them. And that scale down here is called a vernier scale. So that's why they call it a vernier calipers. So what I'm going to do is, it's so hard to see this on a camera, that's not too bad, is what I'm going to do is I'm going to go to your packet. So if you'll get your packet out, there'll be a picture of a vernier caliper, and I'm going to show you how to read that. All right, so I'm going to go to the camera now so you can see this. All right. Now, let me see. I think you can see that pretty well. Let me see here. Okay, can everybody see that? So if you have that packet in front of you, you can see a drawing of the vernier calipers. Now, these are pretty neat little objects. Here's how you hold it. You hold it in your hand like that, and you put your thumb on this wheel. And then what you do is it opens and closes. It'll even talk to you. How you doing? No, it won't. Okay, well, anyway, you can actually do that. And it opens up and closes. Okay, now the idea is that we're going to use this to measure distances pretty carefully with. It's a neat little tool called a calipers, and this is a vernier caliper. So I want to show you this. The first thing you need to know is, and if Ms. String wants to pass one of these out for every two of you, you can do that. And what you want to do is you want to know the parts. Now I actually have that on the next test. I'll have a picture of the vernier caliper just like this one, and I'll ask you what the parts are. So if you want to pause this a little bit and you want to go have one of these for every two people, I have enough maybe for every two people, you could get one of those. And if you have it in your hand, then I'll wait for a little bit. And like I said, if you have it in your hand, we can learn how to do this. All right, so the first thing I'm going to do, if it's in your hand right now, I'm going to ask you to point to different things. The first thing I'm going to ask you to do is point to the fixed frame. Point to the fixed frame. Now, if you look right here, the fixed frame, I'll give you a clue. When I move this, everything that does not move is part of the fixed frame. So if you look at it, the fixed frame has a shape kind of like a 7 or an L. And so the fixed frame is everything that does not move. Okay, now point to the movable frame. Now everything that moves is the movable frame. Now why do you need to know those words? Because I'm going to ask you to find the fixed scale. The fixed scale is a ruler that's found on the fixed frame. So point to that. The fixed scale. Okay, then find the movable scale. The movable scale is a ruler found on the moving part. Now there's another name for the movable scale. The movable scale is also called the vernier scale. And that's a little tiny marks right here. Now this guy, we say vernier, yet in France, he was a French mathematician. They would say vernier, but he was vernier. We say vernier here. And what he did was pretty ingenious. He took a distance, like a centimeter, for example, and he took 90% of that distance and cut it into 10 pieces. You say, well, why would anybody want to do that? And I'll show you how you can do this, all right? Now let's go with the parts again, then I'll show you how to operate this. Find the outside calipers. Now the outside calipers, you probably pointed though right here. Okay, that would be right here, outside calipers. You say, now, what would I do with that? Well, I could do this. I could find, like, for example, the outside diameter. Now, you don't want to squeeze this too tight. You want to be firm and snug like that. But now, that's really hard to do with a ruler, to find that diameter like that. But it's pretty easy with the calipers. Okay, now I've got the measurement here, and I'll show you how to read it in just a minute. Now find the inside diameter. find the inside calipers. And what we do is, that's pointing these little things up here, and you say, well, what are they going to do there? And I gave it away. It's going to measure the inside diameter. Let's say I really want to know the diameter of that inside of that Erlenmeyer flask. I could put this in here and open it up, and until it's, there you go, kind of snug. There we go. The good news is, whether I use the outside calipers or the inside calipers, it'll still read on this little scale here. And I'm not done yet. What if you, for example, wanted to know how deep a hole was? Well, we have this thing on the bottom. It's called a depth gauge, and it actually could do the same thing. I could measure this until I got to the bottom, and I can still read it again on this little frame, on this scale here. So we have outside calipers, inside calipers, and a depth gauge, 3-in-1. This is a neat little tool here called a vernier caliper. Well, now what we need to do is, why in the world do we need to have a vernier scale on a calipers? You can find vernier scales on other things. So what I want to do is, and this is going to be the most complicated part, so look right here, in your handout sheet, go to the top. Now what I'm going to do is I'm going to magnify so you can see it really well. All right, you should be able to see that pretty well. Now, what I'm going to do is, when I close the calipers, right there, on the scale, the 0 on the movable scale, called the vernier scale, the 0 on that scale should line up with the 0 on the fixed frame. Now, what did I just do? I just zeroed my instrument. I made sure 0 was 0. Now, what I'd like you to do is, you're going to eventually open this up at some random distance, like that. You say, well, how do I read that? Okay, here you go. Step 1. You always read straight up from the 0 on the vernier scale. So let's go over here to this drawing. You see this drawing right here? On this drawing, this is the movable scale, also known as the vernier scale. And they don't put a 0 there, but you know it's 0 because when I zeroed this, the whole calipers, that's where it lined up. So what you do is, you always read straight up from the 0 vernier line, okay? Now, if I look over here and read straight up here, I know there's 3, and that's 4, and that's 3.5, and that's 3.6, and that's 3.7. At this point, I feel pretty certain it's 3.7 something. Now, without using the vernier scale, some of you would say, I don't know, 3.73, question mark. Some of you would say 3.74, question mark, because we know with significant figures, you had to guess that last number anyway, didn't you? So if you had to guess it anyway, then we both might get slightly different answers, wouldn't we? Okay, so what if we do this, though? Here's what vernier scale did. And this is pretty neat. Go down here and look at the vernier lines, 0, 1, 2, 3. One of these lines down here will line up really well with one of the lines up here. Now you see this is not lining up, not lining up. We're getting closer. And wow, it might be the one that the big old fat arrow is pointing to. Oh, okay. Now, that happens to be the 4th vernier line. Now, what that means is, from now on, instead of you saying 3.73 and I might say 3.74, we now know that the last number is 4 because the 4th vernier line lines up. And now everybody in the room will get 3.74. It does not give you any more significant figures. It just makes the last significant figure, which is a guess, less of a guess. You don't get more sig figs, you just feel better about that last number. And what I want to do here, we're going to do it again. We're going to come down to this one. And what I'd like you to do is, whoever you're sitting with, is see if you can figure out how to read this one, and then we'll see how you did. The answer is down at the bottom, but remember, you always start from the 0 on the vernier line. You read straight up from the 0 on the vernier line. Okay, now without the vernier scale, I would have said, well, 5.1 and then, wow, it's up there pretty high. I don't know, maybe I'll think 8, Maybe somebody says, no, I think it's further than that. I think it's 5.19, and we're not really sure which person's right because they are significant figures anyway, right? So we're not sure which one's right. But now let's take a look again. Which vernier line seems to line up the best? Is it the 0 vernier line, the first vernier line, the second, the third, the fourth, the fifth? Man, they're not lining up at all. And again, maybe it's the one that the big fat arrow is pointing to, and that is the 9th vernier line. So now everybody in the room will say 5.19. That's pretty neat. And vernier scales, again, can be put on any instrument, but it happens to be on a caliper, so we call it a vernier calipers. All right. Now, I'm hoping you're going to train each other on that. So what I would do is before you start your mini lab and you're trying to train each other, I would take some random distance like that, and then I would, and I always use a magnifying glass. You don't have to, but I try to get it where I can really see it well, and I read it without using the vernier scale, and I say, well, it's 13.23, and I know that I'm going to look somewhere close to the 3rd vernier line and see which one I think lines up the best, and then if it's the 3rd one, it's 3, if it's the 4th vernier line, it's 4. Now, with a little bit of practice, you'll be able to, all right, with a little bit of practice, you'll be able to use this and feel like, hey, that's a pretty neat little tool there. Now, just in case you're saying to yourself, whoa, what? I didn't understand what he just said. He went too fast. What I'd like you to do is, if you'll take a look on the next page, look at that. You get to practice. There are 5 more times you can practice. So what I'd like you to do is, I'm going to go ahead and in the video here, it's going to be a pretty short video, but what I'd like you to do is, I want you, when I get done, I want you to go find things that you can measure with the vernier calipers, and then try to, you write down what you think it is, have the person next to you tell me what they think it is, and just want to practice with the vernier calipers. Okay, and you could even use the outside calipers, the inside calipers, or even the depth gauge, like that. So if you get really comfortable with that, I'll feel good about that. But before you do it, I want you to take a little time with you and your partner and say, what do you think you would read here? What would you read for the next one? What would you read for the next one? So there are 5 of these on that paper, and I would like you to, as a class, try to agree on what the number is. And then when you actually get a real vernier calipers in your hand and some magnifying glass, you should be able to read this. Now, before you start the mini lab, again, and I want you to try to do a little bit of practicing today. If you want to practice a little bit with the graduated cylinders or a little bit with this, you can do a little bit of practice today if the teacher allows you, okay? But when you're doing training, you have to make sure that person is reading the same way you are. One of you may be making a mistake. Now, we get ready to do this thing called Density Detective, which is about a week-long project worth about 140 points. And I'm not necessarily going to tell you who your partner is going to be, but wouldn't it be nice to know that whoever your partner is, they were trained well? And that's what you're doing right now. You're trying to train each other and say, everybody that I've helped, they're really good at measuring with the balance. They're really good at measuring with a graduated cylinder. They're really good at using the vernier calipers. They're really good at measuring with significant figures. And that's what you want to do. You want to be very, very exact. Okay, we're not doing about. So you take your time and you'll make a difference. If you go to college and you take a lab and people notice, look at that person. He's being really exact. Well, that's great. That's what I want. I want them to say, that person actually knows what they're talking about. They must have done something with instrumentation. And by the way, instrumentation is a fancy way of saying how to use an instrument to get the best number. How do you know what you're getting is the right number, like that? So anyway, what I want you to do is work on these 5 here and make sure that everybody in the class is getting the same answer. Then get the real vernier calipers out and measure some random objects, and then see if you can learn how to use the vernier calipers. And I think that's about all I have for today. Tomorrow you'll be starting a kind of a mini lab, But before you start the lab, you want to train each other again. Say, let's train each other on mass. Let's train each other on volumes and reading the meniscus. And then you'll have a series of about 6 or 7 tasks that you have to do in the next 2 days. So on Wednesday and Thursday, you'll have to finish the lab with really, really good numbers. Just tell yourself, I want to get the best numbers I can. And I call it pre-density detective because if you make some mistakes on this, you won't make a mistake on density detective. And I don't want you to. I want you to do really well. But you can make some pretty big mistakes when you're measuring. All right, well, I hope you have a great day, and do your very best always. And I will see you pretty soon. Okay, well, bye.